Next question. So this particular starting material is treated with NBS, N-bromosuccinamide, and whatever the major product that is obtained as a result of this reaction is subjected to alcoholic KOH on heating. So we know the reagent NBS, N-bromosuccinamide. So we have this N-bromosuccinamide as this is N-bromosuccinamide, and the importance of this reagent is that it brings about allylic substitution. Bromine atom, that is bromide form, attacks the allylic position, that is hydrogen at allylic position is replaced by Br minus, and hence we call allylic substitution. So bromine atom will be substituted at allylic position. But how many allylic positions we have? With respect to this double bond, the hydrogen here, we have the hydrogen that is attached to at this position is one allylic hydrogen, and here we don't have any allylic hydrogen. With respect to this double bond, we have here one hydrogen. In fact, we have more hydrogens, so this is hydrogen is also allylic hydrogen, and with respect to this double bond, we have one hydrogen here, allylic hydrogen. So the question arises, which of these allylic hydrogens will be replaced? So when we replace this particular hydrogen atom, the bromine atom will be formed. The bromine atom will be substituted here. And in the next step, if you observe alcoholic KOH heating, and this alcoholic KOH heating is the reagent for dehydrohalogenation. So in the next step, the HBr is eliminated to give double bond. But why not? The double bond can be formed with respect to the bromine substituted here and with respect to bromine substituted here. With respect to bromine substituted here, double bond will give here. Here already double bond is there. This hydrogen when replaced, bromine can be here and double bond can be formed here. And thereby the replacement of this hydrogen, which is tertiary, will go faster than this to give more substituted alkene. Further, this double bond formed here will make the substance to have aromatic character. So thereby, when we carry out the reaction, the major product Y formed is the first step in the X, because X and Y respectively is asked. So X possibility is here, and here if this hydrogen is removed, why not double bond can be formed here, but this is forming outside the ring and it is not aromatic. So therefore C is wrong. Here this particular hydrogen is removed rather than this hydrogen, so A is wrong. Here this particular hydrogen is not removed, instead here the hydrogen is replaced. That is not allylic substitution at all, so therefore B is wrong. Now when we come to the D option, what we find is that this particular allylic hydrogen is replaced by bromine, by NBS, and further double bond is formed here that is responsible for the aromatic character, and thereby D is the answer. So when we look into the complete reaction, we find, so this when treated with NBS, so this hydrogen being now replaced by bromine, we get the X as, and here is the bromine. Now when we treat with alcoholic KOH dissolved in an alcohol, and on heating, elimination of HX takes place. In other words, HBr is eliminated, and that results in a double bond. And the question arises whether this hydrogen and this bromine will be eliminated in the form of HBr, or this particular hydrogen and this bromine will be eliminated. So when this hydrogen and this bromine is eliminated, the double bond will be formed here. That gives aromatic character, and thereby this HBr is eliminated faster and give more stable product, and thereby the actual product of the reaction is, this is X and this is Y. Therefore the answer is D.